A few of you asked about this style of LED firework lamp, and it's quite an interesting, the pictures look absolutely great. So I ordered one, and it came from a listing that said, chic 6-watt LED 3D fireworks light E27 vintage Edison bulb bar decor lighting lamp. And it's quite annoying they're calling it a firework lamp because, as well as this lamp being called the firework lamp, this type of lamp is also called the firework lamp. This is the one with a little switching regulator on the base that puts out about 3 volts to a huge array of copper wire LED string. And they also call this one a firework lamp, which is lots of little circuit boards on a stem with a splay of circuit boards coming off all around them, and it's quite a nice lamp. But the firework description seems to be used for quite a lot of them. And I have to say, the pictures look absolutely great. Dare I say, they look a bit better than the real product in real life. So when you get it, it looks quite stylish. It's this metallic globe. I'll just chuck that down out the way. And somewhat telling is the fact it comes in the box with pictures of the filaments, because it is effectively coming from the same factory, as you will see in a moment. So let's plug this in. I have to say that the power consumption is actually just over 3 watts. But to be fair, it does have 6 1-watt filaments inside, as you'll see. So when it's lit, you'll see it flickering here, because it's not actually visibly flickering, but it's just the fact that, it's using a very simple power supply with no smoothing. I'm not sure the power supply is. Maybe we'll take a look at that later. But now I'm going to show you what this looks like. So in the dark, there's no flicker, and it does look quite stylish. It looks better on the camera than it looks in real life, because the camera is creating much greater contrast, and that possibly explains those great looking pictures. I mean, it looks quite stylish. It's got all these 3-dimensional trails going into it, but you can see inside, if I rotate it quickly, you can see that really is just a set of LED filaments inside that. It's very odd. The camera shows it as this very sharp, crisp image with those trails, and what I see is a kind of like slightly washed out metallic lamp, and the trails are not as visible to the naked eye. They're still there, but they're not as vivid as they look in the camera. So savour the moment, because this is about as good as it's going to get. So let's take a closer look at this. So I'll shove the flickery lamp out the way, and we'll take a closer look at how this works. Now, it's using an effect called infinity mirror. If you get a piece of mirror, solid mirror, and a gap between it and a piece of semi-mirrored glass, then you get this interesting effect. It's a common effect, it used to be used a lot in nightclubs and places like that, and you can still buy infinity mirrors as a sort of visual effect. But if, say, for instance, you put a light bulb in the middle here, with a filament, you'd be able to see through the front, you'd see the filament, plus you'd see the reflection of the filament, plus that would bounce off this semi-mirrored glass, and you'd see a reflection again. And what you end up is this chain effect of these diminishing intensity things just trailing into the distance, these points of light. So what they appear to be doing with the lamps is that the lamp glass has this solid mirror on the inside. It's not quite 100% solid mirror. That's why it's looking a bit diffused. Maybe there are some that are better, but it's got little holes through it. Just little specks that have been made through it. These little, I'm not sure how they do it, little droplets of something that looks like it's almost had sprayed on it that the mirroring hasn't stuck onto. And then it's lit from the back with the bright light source, and it shines through the holes, and the 2 sections of the mirror are the inside of the glass, then the solid glass itself, and then the outside with a partial mirroring the outside. And that means that you actually see, when you look at the lamp, you're seeing that dot with the light shining through it, but echoed and repeated several times, and it creates that sort of wee trail of those points of light. And the best way to see that, I'm going to just focus up. This time I'm not going to use a box of broken glass. I've got a nice new box here, which that lamp came in. So let's focus up on this. How's that looking? It's looking pretty good. Let's just have another go anyway. Yes, that looks pretty good. And let's take a look inside this lamp using an X-ray. So I've got the X-ray here. Here's the X-ray, and here we go. Right, So we've got the standard filament arrangement inside. It's got 6 LED filaments. It's very flickery now. Let's actually turn that off because that is quite annoyingly flickering. And here is the glass, and on the inside it's a sort of bronzy coloured mirror effect with those little holes through it, and then the outside it's a sort of bluish colour. They've used multicolours here. What I'm guessing is it, I don't think it'll be metal sputtering, is it? It might be metal sputtering, but I wonder what they've used to actually keep it off these little holes. I mean, take a look at this. I don't know if you're going to see this easily, but there are sort of holes through the back of that. What if I shine a light through the back of it? There we go. There are the holes. In fact, now I'm doing that. Let's turn it round and shine a bright light in and see if we get this sort of mirror effect. Yeah, you're getting it. You're getting this sort of mirror effect. But I have to say, one of the things that is ruining this effect is actually the fact that the inside mirroring isn't actually enough. If it had been really solid mirror, like an actual mirror, it would have shielded more light. That's what's making this lamp look quite diffused. Right, here is a lamp full of just broken glass. Lovely. Let's see if we can get that out now. I shall zoom back out and we shall investigate. Actually, you know what? Maybe I should clean all the broken glass up first. Yes, we'll do that. One moment, please. That was quite a lot of broken glass. I may have used the X-ray machine at too high a setting. So I've got rid of most of the glass. I've wrapped this in tape to try and stop lacerating myself. The circuit board is tiny in the bottom of this. I think we should investigate this circuit board. I'm not sure if it's going to be a capacitive dropper or if it's going to be one of the clever little self-regulating sort of chips that just basically regulates the current and dissipates any excess as heat. I will say that I had it plugged in for a while, and although it's fairly low wattage, about 3 watts, it did seem to waver down slightly as it warmed up, but not really decisively, not like some of the other ones that do self-regulate thermally to quite a severe degree. So there's hot melt glue, there's what looks like a capacitor in the bottom. This looks like it may be a capacitive dropper. A capacitive dropper using a fairly standard size of capacitor. And hot melt glue. Oh yeah, okay. Shall we get in a bit closer here? Yes, we shall. So there is what looks like a capacitor in the bottom. Let's remove the stud out the base completely. Oh yeah, that is a standard sort of metal film capacitor. So let's get that circuit board out of there completely if we can and take a look at it, although it will be pretty much textbook. There'll be some surface mount components like a bridge rectifier in this. Let's see if I can get this narrowed mess of sharp metal away from the narrowed mess of broken glass without actually shredding my fingers in the process, which may still happen. I would say I've not really bled heavily on a video yet, but I did actually bleed quite heavily once off video when after giving a wee safety announcement how, contempt for health and safety with knives, and then actually stabbed myself quite deeply with a knife. Excellent. These things happen. So lots of hot melt glue holding this in. The capacitor folded neatly in the bottom. There's the bridge rectifier. There's a resistor. Is the resistor going to the output? I think it is. Discharge resistor cross capacitor. Tell you what, I'll finish getting this circuit board out and then I'll just doodle the schematic down. I mean, let's do the complete job here. It's not going to be a surprise. It is a capacitive dropper. We know that already, so it's not going to be earth-shatteringly complex, which is just ultimately it's a cheap way of achieving the current regulation through the filaments in these lamps. One of the nice things about the LED filament lamps is the high voltage across these, because it is a large series array of LEDs inside these filaments. So in this case we've got what looks like a cluster of them in parallel going up and then going back down again. So the current is just divided between the 3 filaments on either side, but the combined series voltage is high enough that it doesn't require much circuitry to actually limit the current through that. So I'm just going to pause momentarily to take this completely out, and then I'll reverse engineer it. So the circuitry is simpler than I was expecting. It is a capacitive dropper, but rather oddly, it's got the capacitor coming in with the 1 megohm discharge resistor to the bridge rectifier, and then a 470k resistor across the LEDs, just a sort of ambient load, maybe to stop it glowing when just through leakage through the wiring, and then the LEDs. And it looks as though it's got an extra facility to maybe have a capacitor across there too, because it does have that extra set of pads, but nothing is really, I don't see the holes. I can see pads, but I don't see holes there. Unless they were thinking they could actually have an electrolytic in the back here as well, tucked out the way. Bit cramped for space though. What is really interesting though, incidentally, the LEDs here, that is just my impression. It's actually probably about 30 in each strip, so it would be about 60 LEDs total, giving about 60 LEDs times about 3 volts, 180 volts, so there's not an awful lot to drop across the circuitry. A bit surprised there's not an inrush. You know, I'd normally expect maybe an inrush resistor there or there just to try and cut down the surge current through the LEDs, but they don't seem to do that. They seem to minimalise it to extremes. Now, here's an interesting thing. Normally, this is the glass base coming up, and normally you'd expect the globe to come down like that and then get actually fused on to that base. But it's not. The globe is completely separate. Although this bit in the middle is glass, and although it's got the sealing pip here, that pip doesn't actually, it's kind of possibly just used as support. It doesn't actually even lead right through for drawing a vacuum or anything like that. But the tubulation is probably the best way to describe that. But the glass is, if you can just ignore the globe at the moment, the glass is literally just that shape coming down. It's got the glass pinch and it's got the little glass stem and the support for the LED filaments. But it's a completely separate piece of glass to the outer globe. The outer globe is then whatever globe you want, whether it's whatever the shape is, whatever the colour is, whatever the style. You then choose that globe, and in the factory all they do is they've squirted what looks like resin, actually, 2-part resin. They've squirted some in and then just sat the globe over all this existing LED filament structure and circuitry in the base. So I could imagine that, you know, that is just what you're seeing here, but with the threaded base in it, the E27 or B22 or whatever. It'll be just, in the factory they'll have loads of these bases with these sort of LED supports coming out, and then all they do is get, say for instance as an order for the golden coloured Edison globes, they'll get the golden coloured glass Edison shaped globe and just glue it on over this. What about that for mass production? That is just really streamlined production. It makes it super versatile. And the circuit board really is just sat, like that's it there, it's just sat hard against the bottom of that glass. It's kind of flared out, and then the circuit board is just literally glued onto it. And the wires from inside, there's no space at all. The wires are just threaded through, it's glued on, and they're soldered and terminated, and that's it. So very, very neat. Very just super streamlined. Very simple circuitry. So yeah, it's, the whole thing is an interesting visual effect, but the one I got, at least, it was a bit too diffused. There was too much light coming through in areas where there weren't those little pinholes, and it was kind of swamping it out. It was stopping the visual effect of the echo of the light, the sort of reflection, multiple reflections from being seen, but maybe there are better versions. Now, before MD asks, this lamp here with the copper wire LED sort of string inside it and the little 3-volt supply, I have covered this in another video. Can't remember what it was called. I think it might have been called firework lamp. And this one here, if you search my videos for Calex, C-A-L-E-X, you'll find the one where I take one of these to bits as well. I take them all to bits. But yeah, interesting. Certainly worth getting that and opening it. Disappointing the effect does not look as good as the picture, but you know what? Maybe there are better versions. But this one was interesting inside, so well worth getting.